Hello, welcome to SNAB Demola, and today's lesson we're going to be talking all about water. So we all know how important water is as a molecule, but we're really going to break down into its atomic structure, and we're going to talk a bit about how its bonding and its properties are relevant to actual real-life biology. So let's get straight into it. Okay, so we're going to begin by talking about covalent bonding. So water exists as a molecule that has covalent bonds, which is what we define as the shared pair of electrons. Now, throughout us talking about the structure of water, we're really gonna want to have a focus on not going into too much detail, just because that would be more of a chemistry thing. So maybe if you do chemistry as well, this will be a bit more important. But for biology, we don't want to go into excessive detail. So in terms of covalent bonding, we define that as having a shared pair of electrons. Yep. So a shared pair of electrons shown here and here between the oxygen and the hydrogen is going to form these strong covalent bonds between the molecules. Now, when we have covalent bonding, we can also have this concept called polarity. Now, in terms of polarity, we define that as an uneven sharing of electrons due to one atom being more electronegative than the other, which gets a dipole. Really, really confusing. So let's break it down. Now, what we mean is that in the molecule, one of the atoms is going to attract that shared pair more strongly than the other one. So for example, in water, it's going to be oxygen. So oxygen is going to attract that shared pair of electrons more strongly, bringing it closer towards itself, which is going to create a slightly negative charge in a way, and that's what we call a dipole. So this is represented by this delta minus here. If the electrons are going to be closer to oxygen, then that means they're further away from the hydrogen, which is going to make hydrogen a bit more positive. So that has a positive dipole. Now, again, polarity. If we're doing chemistry, that's when we're really going to focus on that. But for biology, I'd say that's the extent to which you need to know it. Cool. And what's really, really great is that we can form hydrogen bonds because of these dipoles. So you see the lone pair of electrons. So this is, if we go up, this lone pair of electrons, I'm going to do it in purple. They're represented by this. So these are the electrons that aren't involved in the bonding, right? So they're able to help to form hydrogen bonds with other water molecules, which is going to be really, really important when we talk about its properties. So this here is a hydrogen bond. Okay. One thing that the examiner absolutely loves, and I mean completely adores, is to say that hydrogen bonds require a lot of energy to break. Say that exact sentence in the exam, the examiner is going to love you. Cool. And the hydrogen bonds being strong and there being a lot of hydrogen bonds between these water molecules are going to help to make a lot of the properties of water that we're really interested in. So, first one that we're going to talk about is the specific heat capacity. Now, if we go a throw back to GCSE physics, we're going to define specific heat capacity as the energy required to heat up 1 kilogram of a substance by 1 degree Celsius. And for water, that tends to be about 4.2 thousand joules per kilogram degree Celsius. Cool. Like we just said before, there's a lot of hydrogen bonds that require a lot of energy to break in your water molecules. So that's going to make water a really suitable habitat for fish because obviously the temperature of the water isn't going to change too much. Cool. As well as this, it's going to make your body temperature really stable because yeah, like we said, a lot of energy is needed to break these bonds. So that means if the water is staying at a fairly constant temperature, it's going to be really useful for our bodies. We can control like your enzyme reactions and stuff like that. And also it's going to mean that your fish aren't going to boil as well when they're in the sea. Cool. Latent heat of vaporization, again, we're doing another throwback to GCSE physics. We're going to define that as the energy required to change 1 kilogram of a substance from liquid to gas without a change in temperature. Really, really important, without a change in temperature. What does that mean? Well, it means that when you're evaporating water, it's going to release a lot of energy because there's so much energy stored in those hydrogen bonds. So it makes water really, really useful as a component of sweat. So I hope you'd remember from GCSE that when we sweat, the water is going to evaporate and that's going to have a cooling effect. And that's just because of this really high latent heat of vaporization. Another really important thing about water is its ability to be a really good polar solvent. So water, you can see these molecules, they surround your positively or your negatively charged ions in different ways. So like if it's positively charged, the oxygens face towards it. If it's negatively charged, the hydrogens will face towards it. And surrounding that molecule is going to help that molecule to become dissolved inside of the water. Happy days. Why is that important? Well, it's because it will help you to allow chemical reactions to occur in cells. But also, more importantly, I believe, is that it's going to help you to transport metabolic products. So these polar metabolic products, so like, for example, glucose, and again, some ions like this as well, if you can dissolve them in water, you can transport them all across your blood plasma, which is made of about 90% water. You can transport all of this in your blood plasma, and it can go to wherever in the body it needs to go. So that's another really, really important function of water. So almost at the end here, we're going to talk about cohesion and adhesion. Now, we're not going to dwell on it too much in terms of this video, just because it's going to become really, really more important when we're talking about xylem and phloem, and maybe in that topic 4, or be your plant biology, whichever example you do. But what cohesion is, it's going to be the bonding between water molecules, whilst adhesion is going to be the bonding of water with other molecules. So again, this is going to become really, really important when we talk about xylem transport. But for now, I'd leave it at those definitions. And I've kind of drawn this like complex of water molecules all being joined together, just because you can now see about how we're going to form these hydrogen bonds between a lot of different water molecules. Cool. Density is also really important. So water is less dense as a solid than it is as a liquid. Why? Well, again, let's look at this diagram. There's so much space between these molecules. So again, if we go to another throwback to GCSE, this is chemistry actually, but when you have a solid, you have a more ordered arrangement of the particles, whilst as a liquid, they kind of just flow over each other. You get what I mean? So by having these spaces by having your molecules in a really ordered state, you get these spaces where hydrogen bonds are forming between water molecules, and those spaces means that there's less density. So that's another important property of water. Okay, so again, I feel like this topic is not too long, so we're going to go into a question now. A student investigated how pond organisms survive during winter when the surface of the pond freezes. They found that the water below the ice remained liquid and contained dissolved oxygen and other substances needed for survival. Using your knowledge of the properties of water, explain how water helps pond organisms survive these conditions. This is going to be a 6-mark question. So I'd pause the video now, give yourself some time to think about this, and then we're going to go into a mark scheme afterwards. And here's your mark scheme. So you can read through this mark scheme, see what marks you could have got, what marks you need to maybe revise a bit more. But again, we're always going to go back to the properties of water, and we're going to always be thinking about how hydrogen bonding helps to make these properties happen. So with biology, I feel like it's really important to do contextual questions, just because they kind of throw anything at you in the exam. But like you see here, here's your mark scheme. Have a read of it, and we are approaching the end of this lesson. Okay, so I hope you've had a read of that mark scheme, but now finally here are my A-star tips for this topic if it comes up in your exams. Now, to be completely honest, I don't think this topic is really too complicated in terms of just focusing on water. I think it's definitely worth having a solid foundation and understanding with it, because it's going to help you when you talk about circulatory systems and xylem transport. So I think having a good understanding of this is really important. But I think more likely if they ask you an exam, maybe it will be one of the first few questions just to pick up some marks, or it's going to be related to a more difficult concept. Really, really important. Do not stress over the chemical aspects of water for biology. So for example, understanding what electronegativity is or your intermolecular forces. I would say that's more of a chemistry problem to deal with. For biology, we're just going to focus on mainly the hydrogen bonding and how that's going to help to form the properties that we've talked about in this video. So I hope this video has been really, really helpful for all of you to learn about water and its importance in biology. Feel free to subscribe, ask any questions in the comments below. I'll do my best to answer. Thank you so much for joining today, and I hope you have a great day.